Welcome to Study Loop.
The arsenic has 5 valency electrons. The oxygen has 6 valency electrons, and we have 4 oxygen, and the negative 3 up there means we have an additional 3 electrons for a total of 32 valency electrons for arsenic. So we'll put the arsenic atom in the center. It is the least electronegative. We have 4 oxygen, 1, 2, 3, and 4. So let's just put them around it like this, but these valency electrons between atoms to form the chemical bonds. We have used at this point, we use all 32 valency electrons each of the oxygen atoms. They have octet, so that's good. And in our central that also have an octet. So this is a pretty good Lewis structure. Atoms here. What we will find each oxygen is going to be -1. The central arsenic atom that's going to be +1. So we can do a little bit better than this. We had like to this to be as close to the charge on the ions as they can be. So what we can do, let's change this oxygen here. Move this pair of electrons between the oxygen and the arsenic atom. So the when we do that, we have a double bond, right? So now our formal charges, and now all we have a formal charge of 0 on the oxygen and 0 on the arsenic atom. So this is a considered more favorable Lewis structure. We should put bracket around it and then write 3 minus on the outside. Now let's do the ClO2 Lewis structure that we know as chloride ion. So chlorine has 7 valency electrons, oxygen has 6, and we have 2 oxygen plus we have a valency electrons up here. We need to add ion for a total of 20 valency electrons, right? So chlorine is the least electronegative. It goes in the center. And we will put an oxygen on either side. Next, two valency electrons between atoms to form chemical bonds. We have used 4, 6, 8, 10, 12, 14, and 16. Now back to the center to complete the octet, 18 and 20. So this is pretty good. Each of the atoms has an octet. We have used all 20 valency electrons, but chlorine can be found in the third period of the periodic table. That means it can have more than 8 valency electrons. So we will need to check our formal charges. When we calculate the formal charges, we can see the chlorine has a +1 formal charge and the oxygen has a -1. And they are both symmetrical, so the both have -1. That makes sense. -1 plus 1 minus 1, that gives us this negative charge here, but we want our formal charges to be as close to 0 as possible and still have this negative. So let's see what we can do if we move a pair of electrons from an outside here to form a double bond. That should get rid of this +1 charge here for chlorine. So let's recalculate our formal charges and see how that work. Chlorine now has a formal charge of 0. The left oxygen right here didn't change, it's still negative 1, and then the oxygen in right side here now has a formal charge of 0. So this is the better structure. One last thing, we do need to put brackets around it. So it is shown that it is a negative ion, that's the best structure for ClO2 minus. I hope you understand this well. Thank you.